Because of that, you can see 1500 byte, because this is the size of the data and path or the packet. Okay, now you can better understand why we need to add path in some cases when we are sending a packet with less than minimum size of the Ethernet frame, and you know that why we need to use the maximum size of packet 1500 byte, and the maximum Ethernet frame size is 1500, for example 18 bytes. And we have another detail about this information, but it is not suitable for this for example class. We will talk about them in the future course, in the future classes. Very good. Until now we learned about the Ethernet frame. Now you know that Ethernet has some tasks, has some jobs in the data link layer. It should create a frame from the packet, and also Ethernet has some jobs in the physical layer, okay, about the for example fiber optic, about the copper cable. And let me to talk a little about the devices, for example hub and switch, and the differences between the hub and switch in Ethernet. You know that in our networks we are switches, but in the old days we use the hubs. Let me to talk about the devices that we have in the Ethernet LANs. This is suitable for us because we will learn about the configuration of the, for example, switch, about the maintenance of the switch. It's necessary to understand some of the topics about the Ethernet LANs devices, or some of the for example terminology such as the duplex, such as the half duplex, full duplex in the Ethernet networks. After that we will be ready for understanding the more detailed, for example configuration or some other things about the Ethernet LANs. Okay, in this part I'm going to talk about the Ethernet devices, for example switch and hub. Also we will learn about the router in the future videos, but let me to say that in the Ethernet LAN the device that we are using today is the Ethernet switch, not Ethernet hub. Ethernet hub is not an efficient device. I will talk about that and you can better understand it, but now I'm going to compare these two devices, the hub and also the switch. But before starting to talking about the Ethernet devices, let me to emphasize that in Ethernet we have error detection, okay, with FCS as I mentioned before, but we don't have error recovery. This means that when you are finding one error or one noise in the packet, in the frame, you need to discard it, and this is not the function or responsibility of the Ethernet to recover it. We have another protocols, for example TCP, that the TCP can recover the data. I mentioned it in previous video, and also I will talk about that in the future video. Okay, let me to start talking about the hub and switch. The first thing is that the hub and switch are so similar to each other, okay, in the physical form. Look at here, this is a switch, this is a hub. As you can see here, we don't have any differences. And here is another, we can see another switch or Cisco switch. Other switch, all of the other switch have the similar shape, have the similar ports, for example Ethernet ports, RJ45 ports, and also the fiber link ports, okay. But here I'm not going to talk about the physics of the switch. I'm going to talk about the logical behavior of the hub and switch. As you can see in the left side, we can see a hub. The hub's icon is one rectangle, okay, with the, for example, one arrow, as you can see, and the computer 1, computer 2, computer 3, and computer 4 are connecting to this hub. When you are sending one Ethernet frame, for example, we are sending this Ethernet frame from the C1, okay, with the source MAC. You know that in each Ethernet frame we have one source MAC, and the source MAC is the M1. M1 means MAC 1, and also destination MAC. The destination MAC is the, for example, map 4, okay. This means that we are sending one Ethernet frame with the source of computer 1 with the destination of the computer 4. The hub, okay, should not forward this traffic to other devices, but hub doesn't know about the destination MAC. Because of that, hub also should flood the frame, okay, to the other ports except then the receiving port. Look at here, the hub doesn't know anything about the address, about the source MAC, destination MAC, or other parts of the data. The hub only repeats or replicate the traffic into different ports of the, for example, the hub except the port receiving the traffic. This means the hub only is flooding the traffic, and this is not good. Why? Here we have many disadvantages, many inefficiencies. For example, as you know, the C3 after receiving the frame should discard the frame. Why? Or should drop the frame, because the destination MAC is referring to another MAC address than the MAC address of PC3. The MAC 4 is the MAC of the computer 4, not the MAC of the computer 1 or computer 2 or computer 3. Because of that, this frame should be dropped in C2 and C3 also. This means that we wasted the bandwidth of these links. Also about the security, we have some problems. For example, the frame that should be received only by computer 4 now is receiving by all of the computers, and you know that this is not good for security function. Okay, very good. Also, we have some another problems. I will talk about that. When you are using hub, you are experiencing this behavior. But if you use the switch, okay, when you are sending a traffic, for example, from the MAC of the computer 5, the M5 to the MAC of computer 8, okay, assume that here we have M8. M8 is the MAC address of the C8, okay. The traffic with a switch only is forwarding directly to the computer 8, not to other computers. For example, the computer 6 or computer 7 don't receive this traffic. This means that here we don't waste the bandwidth. Here we don't have the security consideration, and we don't have another problems that we have in when we are using hub. Because of that, hub is a legacy device and we don't use hub in our networks. You know that the Ethernet first, for example, published in the 1990s, and in that time, okay, the switches are not the switch does not available when the IEEE first introduced the 10 base T in 1990s. Ethernet switch did not exist yet, okay. Instead, networks used a device called a LAN hub, okay. As you can see, like a switch, a LAN hub provides a number of RJ45 ports as a place to connect links to PCs. However, hubs use different rules for forwarding data, as you can see, and after some years, as you know, we created the switch, and with switch we can forward the traffic more intelligently. Hub is a layer 1 device, okay. LAN hubs forward data using physical layer standards rather than the data link layer standards, for example the MAC address, and are therefore considered to be a layer 1 device. This is an electrical device. Only the hub should replicate the traffic to the its other ports. When an electrical signal comes in one hub port, the hub repeats the electrical signal out all other ports except the incoming port. You know it, okay. And this means that by doing so, the data reaches all the rest of the nodes connected to the hub, and so the data hopefully reaches the correct destination, okay. The hub has no concept of Ethernet frames, of address, of another features about the Ethernet frame, making and it cannot make decision based on those addresses, okay. And you know that the downside of using LAN hubs is that if two or more devices transmitting a signal at the same instant, okay, the electrical signal collides. This means assume that we are sending in one time from the C1 and also from the C2. Let me to show you. This is another frame, okay. In this another frame, when you are sending traffic from the C2 to destination of for example a C3, okay, we will experience the collide of the frames. This means that all of the frames should be dropped. Look at here, from the M2, the MAC address of the computer 2, to the, for example, M3, okay. Let me to show with another color, okay. As you can see, this packet should be forwarded from C2 and then again should be replicated to other ports, for example this port and also this port to the computer 4, and also to the computer 1. Let me to show you. This is for computer 4, and then to the computer 1. Okay, this means that the data, okay, should collide, but these packets should accident with each other, and after that we should drop the data. You know that in one time when we are using the hubs, only we can send only one traffic. First we need to send this traffic from C1 to other PCs. When C4 receives the traffic and the C2 and C3 are dropping the traffic, the next computer 2 can send the traffic. This means that we are using for example, the bandwidth of all of the links one time with one only PC. Okay, for example, when you are sending traffic from C2 to C4, you can send traffic from C1 to C3. This is some of the disadvantage of the hub. Hub only repeats the traffic to the destination, but as you can see in switch we don't have this problem. In switch you can send traffic from the C5 to C8, and in the same time you can send traffic from the C6, means with the source MAC of MAC 6 to the MAC 7. Okay, and this traffic easily can forward to this computer without any collision, without any colliding. Also, if you want, you can send in the same time the traffic to the other devices. Let me to show you with another color. For example, from the M6, from the Mac 6 to Mac 8. Also, if you want, you can send this traffic. Yes, I know that in one time we can only send one frame to the, for example, C8, but the switch can buffer this traffic and first sending the blue traffic, after that the orange traffic. This means that in switch, when we are using switch, we don't experience the for example, the collision or colliding the frames. Okay, this is so useful for us. Okay, I will talk about that, but let me to show you one important example. This can help us for better understanding the function of the hubs and switch. Here we have a hub. Let me to use one hub here. This is our hub, and after that let me to add 4 PC to the first PC, second PC, and third PC, and for example 4 PC. Okay, and then let me to add these PCs to the hub, to this hub. Okay, the first PC, then a second PC. I'm going to show you the behavior of the hub. Okay, and after that here, and then to the for example to this PC. Okay, now let me to assign one IP address to the PC1, 192.168.1.1. okay, and then the next IP address to the PC2. Okay, 192 here, 192.168 for example 12/24, and then let me to assign the next IP address to this PC, 192.168.1.3. This is only one example. The IP addressing or some other things is not important. I'm going to show you the function of the hub. 192, okay, 192.168.1.4. This is our scenario. Okay, let me to send traffic from the PC1 to the, for example, PC2, from 192.168.1.1 to the 192.168.1.2. Okay, as you can see, we have the replies. Now if you want, I can show you the packets. Here we have the packets. Okay, let me to choose the packets, ICMP. Look at here, when I am sending the ICMP packet, this packet now is going to the PC2. Look at here. Here in the destination MAC address, we have a MAC address, and this is the MAC address of the PC2. If you want, I can show you. This is the MAC address of this PC. Let me to show you the MAC address of PC2, ipconfig/all. Here, as you can see, we have a MAC address. This is a MAC address, and you can compare this MAC address with this MAC address. 0050, 0F, C0A13B. It's okay. Look at here.